Excellent. Thank you very much. And thanks, Barakat. I just noticed, you just pointed my attention to the fact that I wasn't recording this class. And sometimes I get carried away by the discussion and then start recording midway. That's why we have several batches of the same topic. So if you have this class, there's a previous batch, there's the one before it. So it gives you also additional insights to discussions of the same topic. So you will have access to all of those once we have all fees sorted out. So thank you very much, David, for that. Recording has started as well. All right, Lucy, let's hear from you. Good evening, welcome.
Thank you. Yeah, so I was able to, I knew what the driver is at the last class, and use basically by supply or have to be able to build the infrastructure. And I also learned about headroom, which is the space between the ceiling and the floor when somebody is standing upright. So those are the two periods in last class.
Very good, thank you. Ibukum. Ibukum is muted.
Okay, sorry. Good evening, all.
Good evening. Well,
I cannot hear very well, so I'm trying to know why. But okay. All right, sir. My takeaway for last class. How would I put it that the different parts of the building and what is required as a minimum standard, at least, to say you have a safe and a secure facility. So definitely picked that, the plumbing aspect, drainage and all of that, the build and the fire aspect, the electrical aspect, and all of those aspects of the building. And of course, beginning to watch out for my own side too. Mm-hmm. And also definitely the building code, the class kind of whet my appetite to want to know more. So what's it called now? The code, Nigerian code, and then to go through it and read it, and then of course imbibe it into whatever I'm doing. So and then the class talked about the defect liability period, which I think is very important in our work also, so that we can get we can get value for what we are paying for, and all of that. Yes.
Okay, thank you very much. For the building code, you can actually download it online for free, or you can buy a booklet of it. There are probably 4 to 6 editions, of the building code. But even with the several revisions of the building code, it's not still been passed to law by the National Assembly. So Nigeria, I'll say, is as a signatory to the International Building Code. We basically just, latch on that fact that there's an international building code and we're part of that convention as a country, plus the fact that most states have model building codes, so which is built into all of those agencies. In Lagos, you hear of Building Material Agency, you hear of Swamp Area Agency, you have the water people, you have the elevator people, you have all kinds of building agencies, regulators for plants and the rest in Lagos. So they are all part of the building code, because a code is a combination of so many regulations. Okay, so whether we have it as a single book or in several agencies enforcing different aspects, we all accommodate them as part of the building code. So thank you. Get one, download it and read. Olayemi, let's hear from you. Take away from the last class. Should we say Olayemi is in class or not? Looks like Olayemi is it's cruising on the road.
Yes, sir. Good afternoon, sir.
Good afternoon.
last week I learned about, so my colleagues have mentioned some of the things that I learned already. But I also want to add is about renovating the building. Get the permit to carry renovation without even knowing that I need to go and get any approval from anybody, any government organization.
Yes.
So we've been doing it, and it's not the right thing. So it's one of the major things that I took home.
It's not, yeah, go ahead.
So then the deferred liability periods too. Apart from the renovation, I also learned that it has to do with both the new building and all those things. So I also learned about that.
Okay, thank you, Lion. So for that getting a permit before renovation, it's not for all levels of or classes of renovations. You could just repaint your building, for example, or change internal ceilings, or redo your electrical wiring internally, and so on and so forth as your renovation. You don't necessarily need to go for new permits when you do simple improvements to your facility. It's when you do make changes to things like the use of that facility, you must get approval. Any structural change, whether it means combining 5 rooms into a hall, for example, or partitioning a hall into 5 rooms, those are structural changes. Any additions or demolitions, partial demolition of the building, you need to. So addition, whether you're adding a new floor or extending the building, you need to. Even when you are positioning your fence, you are trying to create a fence, you probably have a compound, you've not had a fence for a long time, and you now want to build a fence, you need to get permission. So basically, those are the kind of renovations or changes. So we call this remodeling. You get approvals for remodeling for basic repair, upgrades, and improvement of facilities. You can just go ahead, provided the facility will still remain looking, feeling like, and in use for the purpose it was originally approved. If the look and feel and structure is going to change and the purpose is going to change in any degree, you need to get approval. Well, we can excuse ourselves for not knowing before. Now we know.
That's the relief, sir, because we do some painting, like you said, changing the roof, sheet, all those things.
Yeah.
I've been thinking that this time I'll be going to go and get permits and how much.
If you're changing the roof sheet with the same, type of material or a different material of the same weight, no new design, no need for approval.
Okay, sir.
But if you're going to change the design, that's a structural change.
Okay. Okay.
All right.
Thank you, sir.
Thank you. Let's hear from Daniel. Take it away from the last class.
A very good evening to you, sir, and everyone in the class. Okay, I was on and off in the last class because of colleague's wedding.
Yeah, sure.
I think I was the only person that joined the class.
Okay.
I mean, after the during the wedding.
Oh, okay, I see.
Yeah, I was the only person, so in the later joined. So I was also on the road. So I think what my takeaway was deferred liability period, which is usually takes effect after, and call it handing over, but you made mention of commissioning too. So in the other modules that you treated, so which is 6 to 12 months, so the contractor has to, or the vendor has to come back and then rectify whatever the defects might be. And usually stated in the contract, but what I'm familiar with, like in the real estate business we are doing here, we don't state it. We only just tell the client, maybe like a gentleman agreement, okay, If you have issue within 3 months to 6 months, usually 6 months, because if you, a typical Nigerian will actually going to damage, some people actually intentionally spoil their fittings and all that, and tell you that, that because you gave them this and all that. People always need maybe with what attention. So they will spoil the tap, or maybe their children will write on the wall and I'll tell you, you need to come and repent. I said, this is not defect. You know, when they say defect, maybe as a result of, there is something we call flaking paint. Flaking paint, that is, and then maybe is a leakage on the retic, maybe that occur as a result of joining the reticulation. You know, so that is obvious. But for somebody to call you that because there's a stain handprint on the wall, you need to come and paint. So you need to actually understand what aspects that defect liability is covering.
Okay.
So I agree with the model that there is a need for it to be stated in the contract.
Sure. So I appreciate that. That's a very good point. Sometimes we mistake defect liability with warranty.
Yes.
They are two different things. Defect liability means that we did not do it well. So within this period, if you find something that we did not do well, call our attention to it.
Absolutely.
It does not have anything to do with wear and tear.
Absolutely.
If you use it, it wears and tears, defect liability does not apply. It means we did it well, and you used it, worn it out, broke it. That is not defect liability. That can be covered by warranty. Warranty acknowledges that if I deliver this product to you and you are using it in the normal course of use, I warrant that it should not break within 6 months or 1 year, which means as you are enjoying it, I'm giving you a guarantee or a warranty that you should be able to enjoy it for more than 6 months or 1 year. So if while you are using it, the normal wear and tear now proves to be faster than I anticipate as the manufacturer or supplier, then it's my job to come and replace that item during that period. So they are different. Then the third category is accidental damage. Neither warranty nor defect liability covers accidental damage. So those of you who are in properties who are doing all this sale agreement and the rest, take time to analyze these things so that customers know. What you just referred to as customer breaking something and coming to call you just because it's close to defect liability period so you can give him a new one, it should have been written off under accidental damage. Accidental damage is not part of our coverage, right? So if somebody who is very big, for example, right, decide to sit on something that was rated for 60 kilos or 90 kilos and the thing breaks, that's not defect liability. There's a rating that you are aware of. If you are bigger than this, it doesn't going to buy a scale. The scale say not more than 120 kg. And then you start on top of the 180 kg.
I had a similar experience when somebody I was weighing about 120, 130 was trying to hung on a burglary that is not strong. You can see that it's not strong. So you can imagine somebody with a client with such weight would definitely going to shake the burglary that's been neatly installed. I said, you can see it's shaking. So I totally agree with you, sir.
Yeah, so spell it out, please. Okay, who goes next? Tracy, are you good?
Sorry, sir. I just want to confirm. So will it be safe to say what's the warranty has to do with product, while defect liability period has to do with service?
So you're trying to make it look like tangible, intangible. No, it doesn't apply. They can both apply to the same thing. They can both apply to workmanship. They can both apply to product or materials. Yeah. But we usually use it for a whole package, right? So you say all the civil works, all the electrical works, you understand? Whereas each of those components might have different warranties. The different liability will encompass the whole system as a contract. I'm not seeing anybody in class again. Who's going to go next? We're all on ghost mode, right? Aha, let's hear from Adedayo. We saw you before. You can unmute now.
Good afternoon, everyone.
Good afternoon.
Yeah, last class, I was able to gain a very crucial information as regarding the building regulations and the vent aspect of it, whereby you have POP being changing color from white to brown because of it not being ventilated. That caught my attention, and it's really affecting me because of it, we've changed roof, we changed ceiling, we changed so many things. Now still having the same issue. So after the class, I now find out that the roof pitch is very low, and there is no way for cross ventilation. But there is solution now, but the financial aspect of it is something else again. But during the last class, I was able to get to the root of that problem. Like it is ventilation that is affecting the POP to change color and not roof leakages.
And there are new extractor fan systems now that are fanciful, nice. They'll look good on the wall that you can actually use to suck out moisture and suck in air into a space. So there are solutions for all of that now. So you cannot be constrained by your structural confinement. You can do mechanical solutions to increase ventilation. Okay, Tracy, you're welcome. Is Tracy giving us a feedback on the last class? Okay, so
Sorry. You're asking. Hello?
yes, your audio is kind of breaking.
Hello?
Yes, we hear you now.
Okay. I'm sorry. The last class I was at a wedding, so I didn't attend it.
Okay, yes. I remember.
Yeah.
I remember.
Sorry about that.
That's fine. Okay.
All right,
so,
thank you.
No problem. All right, so let's go to who's there again? So what is your name? The person that signs in as Power Ranger. Lawal, okay, fantastic. Lawal, were you in the last class?
Hello, sir. Good afternoon, sir.
Good afternoon. Were you in the last class on Saturday?
Yes, sir. Although I came very late. I joined very late, but I was.
Did you pick anything?
I'm just trying to review the material.
Okay, that's fine. All right, go ahead then. Tammy, do you want to speak? Give us your takeaway from the last class.
Good afternoon, sir.
Good afternoon. Go ahead.
All right. At the last class, I was there were laws I never knew that were actually very applicable, like changing the color of your house to another color. I never knew that you have to write the last pack in order to change a color. I just feel that since it is my property, I have the legal authority or the legal right to change such. Because even where I work, I had never even come up with a package like that to tell the resident that, see, you cannot just change your color anyhow, because this is a common practice here. People will say, okay, I don't want color again. I'm not painting. I want to use like marble, stones and everything. So when I had that again, I said, my journey is still far. But that was my very take home. And then he mentioned that we should know the law and regulation that is pertaining to what we do and our related field. so that it's not just when they come to you, you're also equipped with information. You are not just talking blah, 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 blah. You are talking from a point of knowledge. So he said all that he gave us might not be the totality of it, but we should research. And I think he promised us that he's going to send one to the platform so that we can all read and research about it.
That'll be fine.
Very
That'll be very good. Very good. Thank you so much. We have now used up our time for feedback from the last class. We'll now look at a possible solution session. If anybody has any burning issue, work-related challenge, customer-related, stakeholder-related challenge that we can, walk through for another 5 minutes. Okay, so let's hear from David. You have taken the slot. You're muted.
All right, sorry about that. So one of the buildings I'm in charge of, some 2 months ago, 2-3 months ago, we discovered termites were, coming out from the walls at different points. So we got a company, a cleaning company who can also fumigate to help us treat the termites and all that. Yes, from the points they came out before, we were not experiencing them before, but we're not experiencing them again. I mean, last week, we did a job. We opened a wall and created an entrance there. So immediately the guys finished breaking the wall, we saw a path of termites, that there's a way they build their houses like that. Mm-hmm. So I want to know, what's better way? Is there any sure way, better way of taking care of termites?
Okay.
Is there any better way? Because one of the first things we also experienced was that some of our doors, they were eating them, and just at the base of the door, you'll be seeing like sawdust, and then sometimes when you touch the door, you just realize that everything inside has been eaten up. You just touch it, it's like paper.
Yeah.
So I don't know if there's any way in which this can be.
Okay, let me just lay it out as simply as I can.
Okay.
Termite infestation should be prevented at all costs. Because termites have, what they say, cat with 9 lives, right? They are very terrible insects. They have adapted so well. You can kill all the termites that you can see. And what kills them will not kill their eggs that are in cysts. Like dust.
Mm-hmm.
Those eggs have the capacity or potential to stay for a long period until the condition is right for them to hatch.
Wow.
So that's why termites and some of those bugs should really be avoided. Now, if you are having termite infestation in your building, you need to actually do an investigation that traces you to where they have their mounds, where they're actually coming from. It may not be in your site.
Yeah, actually, in fact, I think that is very true, because there's this building beside us. It's more like an abandoned building.
Mm-hmm.
Right from outside, you can see visibly.
Yes, that's been taken over.
They've taken over the house.
Exactly. So that's number 2 points. First one, prevent it as much as possible by the way you build your building materials. You must use wood that are so well cured that termites, when they come on it, they cannot even do anything to it, right? And your concrete and your cement should be such that termites cannot have any impact on it. So they'll just leave. It's not something they can borrow through. But commonly in step 2, find their source. So in that site beside you, find the owner, get access, and invest with them in efforts to excavate and kill their source, because it's a colony, right? The more you kill where you are, the more they send more battalions to come and colonize, right? So until you go to their base to actually demolish them, you know, uproot their queen and stop their entire operations by, you know, whatever chemical or other means of fire and the rest people apply. Until that operation is dismantled completely, you will still see them keep coming back. That's just something you need to be conscious of. Once you've done that, you now do a termite specific treatment. This time, you would apply 2 types of treatments. The one that's focused on the termites and the one that's focused on their eggs or on their on the cysts that they leave behind. They leave like spores, and they're not really termites. You think these ones are nothing. You just like sweep them up or something, but they can hatch into something later. So basically, you want to deal with it from those 2 points. Okay. That's just some ideas I've applied whenever I've encountered termites. Topical application, this is where they attack, let's treat here, does not work. I have lost a whole photo studio that I built. You know, when I was growing up, I was a photographer. So in Benin, we had this cultural complex. And I got a lot, like a plot of land there, and I was told you can build your studio. People coming for occasions all the time. So people were making cards, paper cards, and all those gifts. They also built shops in that place. So I built a very nice room and parlor studio using wood materials. But I can tell you, my studio did not last 3 years. It was eaten up completely. The entire building was eaten up completely in 3 years. So when it comes to termites, you can be pouring all those chemicals and they'll still be busy just eating up and eating up and eating up. And they are so smart that they operate in a kind of a stealth way that they can eat up everything inside and avoid scratching the surface.
Mm-hmm. Yes, I've experienced that.
So
common tools.
So one day I went into the studio and opened the front entrance. Everything was okay. I went into the inner studio. The reception was fine, and I fell through the wooden floor, like suddenly. so some stuff. Okay, thank you. So that's the approach. Just follow that approach. Go to their source. Yeah.
All right. Thank you, sir.
All right, thank you very much. Let's get into today's class. I'm going to share my screen now. Is this the screen I should be sharing? No, I don't think so. Okay, do you see my screen?
It's not starting from the beginning.
It's not starting from the beginning, right? Okay, so that means I'm sharing the wrong screen.
Yes.
Okay, thank you for that. This is it, right?
Yes, sir.
Okay, thank you. So we're looking at sustainability and energy management. Now, we're going to look at sustainability, which is like the big picture first. Everything that has to do with the 8 categories of sustainability we'll discuss. And then we will now look at one of the 8 categories of sustainability, energy management, because it is the most important aspect to us as FMs in Nigeria. Other aspects of sustainability might be a big issue for other people or professionals in other climes, but here in Nigeria, energy management is for us the biggest deal. So that's why we're going to have the second section or the second part of the class focused on energy management. So what is sustainability? Development that meets the needs of the present without compromising the ability of future generations to meet their own needs. We provide all that we need now in terms of spaces and services to meet our needs, to live in some, to work in some, to recreate and to worship and to be buried in some. We do all of this, but we also want to ensure that while we are able to meet our own needs, future generations don't have to come and hear of such resources and not see or feel or experience the use of them. Okay? So that's why we talk about sustainability in terms of the 8 categories. As far as facility management is concerned, the International Facility Management Association, IFMA, has kind of simplified this into 8 categories of sustainability. And it starts with the indoor environment quality. Sustainability starts with how we make ourselves feel within the spaces that we live in, how healthy we are in the spaces we live in. Okay, so that's what indoor environment quality covers. And so everything that has to do with how much light you need for your space, are you having that much light, how much oxygen or ventilation you need, how much cooling or heating you need, how much drinking water for that space, everything that has to do with how clean the space is, all of them are factored under the environmental quality for your indoor spaces. And the lesson to learn here is that much of the cost we spend on medical bills today are created out of poor investment in indoor environmental quality. So we create illnesses, building-related illnesses, BROI, or sick building syndrome, SBS. We create those kind of environments when we allow the environment to degenerate to the point where it's no longer habitable, but people are living in those spaces. Something that you can easily relate with is when you are managing a high rise, for example, and you don't have what I'm called ventilation or oxygen flow into the space. You depend on mechanical cooling, but the mechanical cooling is basically just recycling and cooling the air that has been used up inside that space. So you may have very cool environment, but the environment will be unhealthy because there's no fresh supply of oxygen. And the number of people inside that space are using up the oxygen you have in the space. So you create sickness for people and you create asset deterioration with that kind of environment. So we need to be careful about how our indoor environment looks or functions for us to be able to get value from what we have. Then quality of services. Services that are sustainable and minimize the environmental footprint. So the services that we provide, how do they impact on the environment? Okay, so we can talk about services in terms of the efforts that we put in. Are these efforts sustainable? Are there unnecessary steps to implementing the processes that we have? Are there things that could have been done, for example, online, virtually, that we are making sure is being done physically, where people have to travel some distance to meet up, a meeting that could have been done virtually? So many things that decisions you take about how you provide your services need to be managed under the quality of service category. And then waste. Waste is everything that we have as byproducts from our processes. So whether you are painting and you are scraping off walls to prepare the surface, and then you have all those flaked paint packed in bags, that's a waste. Whether it's you're procuring things and you are having packaging and packets and cartons that you probably don't need or don't know how to use again, or you are having items that they've reached their useful life, but they could be reused or repurposed for something else, but you're about to trash them out. Those are the things we worry about when it comes to waste. The reason is that every time any item goes into a landfill, the earth is being punished for yielding her resources. So we take petroleum products, for example. We take crude oil, refine it, we'll get oils from it, we'll service our generators. And what do we do with the oils when they are spent? We take it and dump it into a lake or a gutter or some kind of natural water body. At the end of the day, we are harming the earth, we are destroying the environment, we are making it unable to sustain wildlife or marine life because of our behavior. Okay, so that's the whole idea of managing waste. Plus the fact that every time you dump waste inside a landfill, it creates a toxic buildup. And that can be in form of gases, that can be in form of leaching chemicals that go into our water, that go into our rivers, that go into our boreholes, that come into our holding tanks, put pressure on our maintenance because we are damaging the environment and these chemicals are beginning to affect us. So let's target zero waste to landfills and use as much as possible the recycling and other reuse processes to convert what could have been waste into future or further use. And then site impact, gauge the environmental impact and footprint of each building's operational processes. Every time you come into a site, you clear out all those trees, there's an impact on the ecosystem. You dig a foundation, there's an impact on the soil ecosystem because you are basically just dislocating certain organisms from their natural habitats. And then you create foundations and build superstructures over these substructures. What are you doing? You have now finally encroached, not only encroached, you have occupied, and you have changed a lot of things. For example, the natural flow of ground streams and water have been obstructed by the ground, the walls and foundation you built inside the ground, right? And because of that, the water, of course, they say water will always find its level. It builds up somewhere else, causes flooding somewhere else, or overflows the drains at some point because the natural flow that is subterranean has now been obstructed. That water had no choice but to rise up to the surface and cause surface water around. So sometimes we need to do a proper survey of the land so that we will know what is happening on the land before we come and site our structures. There are some buildings that you'll just find a whole neighborhood having fun. The place is okay. We don't have a problem until a certain structure is built. As soon as that structure is built, then one rainy season is all we have as respite. From then on, we are in trouble. All kinds of crises begin to brew. Not necessarily because of that one new building. It's probably because the natural ecosystem, the groundwater flows, they've been rechanneling themselves because structures are coming up every now and then on their paths, right? And so now this last building is probably the one that finally is the place where they all finally found as their conduit, and then this person now finally builds. What happens is that they are now trapped. Everyone becomes automatically trapped, and that's why it's important for sustainability. So when some people do environmental impact analysis for projects, see corporate organizations talking about environmental impact analysis. These are the things they are trying to look at so that they can see the real impact of their structure or whatever they are going to do as their activities or processes within that site. Now we have energy. Energy is a big deal. Energy is a big deal. It is a big deal because our operations, everything we do in life, requires some form of energy to run it. Okay? And then the energy that we use is now embedded with a lot of waste. So cutting out waste is our number one priority when we come to energy management, ensuring that the energy we use is actually producing a result. So for every kilowatt hour, for example, there should be something you can say, this energy delivered that I got. So that's the first thing, energy efficiency or energy performance, cutting out waste and directing every energy unit used to a productive end. Secondly, the source of energy is becoming a big concern. You know, we're talking about sustainability, which means we're trying to consider how to conserve the resources of the earth so that future generations can see a piece of it to be able to also enjoy when they come here. So the source of energy, some energy sources are fast depleting. They are depleting faster than the earth can remake them. Take crude oil, for example. It took thousands of years of fossil decay to create the crude oil that we are tapping out of the earth today at such speed that by some estimates, from the first time crude oil was discovered to the time the last barrel will be tapped, we probably won't have been 300 years. So imagine 6,000 to 10,000 years of natural process in developing this resource consumed in less than 300 years. What then happens to generations after that? They'll have to find other means to survive, isn't it? So our best bet will be to focus more. Okay, first, reduce the dependence on fossils, which has to do with all of the oil, the coal, and all of those non-renewable sources, and then increase our use of renewable and perpetual sources. The only perpetual source we know is solar. Solar is perpetual. You can always get power from the sun any day, right? But every other one is renewable, which means that as you use them, you deplete that resource. The earth can conveniently reproduce within a short period. For example, using vegetable oil to run vehicles and industries, for example, or using sugarcane, methane from sugarcane to run those industries. You can grow sugarcane in 3 months to 6 months, or even less than a year practically, and replace that energy source. Unlike crude oil that will take thousands or even tens of thousands of years to reproduce. So we should be careful about the sources of our fuel. So if you ask me, I would say in Nigeria, for example, you know that many of us still have a tendency to undermine our public supply. If not for poor management of recent years, Nigeria should have been 100% renewable as an energy source nationwide with our dams. With the Kainji Dam, the Shiroro Dam, and if the Mambila Dam has been built, when the foundations were supposed to have been laid some 30, 40 years ago, by now we would have not only been an energy self-sufficient country, it would have been 100% renewable, because hydropower is a very, very a good source of renewable energy, and we would not have had this petroleum crisis that we are in the country today. So public supply, even as bad as it is still preferred. So instead of me to knock off, for example, as an FM, instead of me to knock off public supply that I know is more sustainable in terms of cost in some cases, not in all cases, but in most cases renewable, because we have a good chunk of our hydropower, our electricity being generated using hydro. I would rather invest in power correction or power quality correction or power quality improvement infrastructure than to invest in generators that, let's assume your current is becoming so low, you cannot power your sensitive devices anymore. I'd rather invest in equipment to, improve that quality and make me use it for longer than to cut it off and go burning diesel or gas. Okay, so that's the whole idea. Reduce cut out waste, and then look at a way to come out from fossil as much as possible. It's not practicable right now, but as much as possible, if you have a renewable source, please focus on how to get that to work for you. Then water. Water is a primary requirement for all of our services that we provide as facility managers, from the standpoint of nutrition and welfare, catering, and all of those hospitality that water does, all the way to entertainment in pools and water parks and the rest, all the way to our cleaning operations. You know, almost all production in the world requires input of water. So water is a very important resource. In fact, the reason certain planets today are not being inhabited by man is because they don't have water. You don't. Man can actually carry the oxygen he needs to go and live somewhere and be able to live in some kind of test tube environment when there is, if there is water. But the earth today has a lot of water, but we need to understand as facility managers that water is not an infinite resource. 70% of the world is water covered, but 95% of that water is not potable, which means it's not usable for almost all of those things I've listed. Seawater. Freshwater supplies is not finite, which what that means is that it does not keep increasing or reproducing itself to replace. It can actually keep in a water cycle like we described, but it also has a way of reducing. And then for water, we also have contamination that's happening every day on our water sources, both the water that is on the surface and the water that is on the ground. So we should be careful. Water resources are dwindling. A few years ago, I think it was 2 or 3 years ago, one of the most beautiful cities in Africa, Cape Town, actually had an acute water shortage. It was so bad that there had to be new regulations, emergency regulation, to prevent people from using more than 50 liters of water per family per day. And I don't see how you would have a swimming pool in such a town where people are, basically, hunting each other down for access to water. It was that bad, right? And you take it for granted and say, oh, we don't have problem with water. We just drill a borehole. And then even in Nigeria, there are certain communities and cities and towns that you don't necessarily have that easy access to underground water because of the way the aquifer is laid. You have to go extremely deep, go through some very serious engineering marvels to get to water in some areas. So you don't play with that. Besides, even if the water is close to the surface or it's surface water, there is some energy employed in bringing the water in, treating it with chemicals and the impact of those chemicals on the environment and making it possible. So why do you want to waste water? Why do you want to waste water? Why do you want to use water that has gone through water treatment plants that you are spending some 200,000 a month to maintain and feed chemicals into to be watering grass, for example? I mean, if I don't know. There are some things we do with water that just makes us realize that we don't get it as professionals. A research was done that showed that if you put on a tap for 5 minutes, or you have a broken pipe and it runs for 5 minutes, it's equivalent to leaving an incandescent bulb of 60 watts on for 14 hours in terms of the real cost energy implication of leaving a tap or a broken pipe running for 5 minutes. It's 14 hours of a incandescent bulb left on through the day. So that's the kind of value we should place on water. Water is not cheap. Water is not free. It's substantial investment we make into getting water. And if you don't know, even the government in Nigeria legislates ownership of water. So if you want to drill a borehole, for example, you need to get certain permits to drill and then pay royalties for taking out that water on an annual basis in lieu of paying to the government to, run water to your site. So in essence, water will cost money no matter how easily we think we find it. So we should be careful how we use water. We should, as facility managers, begin to think about ways to actually measure the water that we use. Start with that point where you know that this is how much water I'm actually using. And this is what I'm using for this type and that type and that type of water. And this is what water is actually costing me. Even if I have to measure to the detail of how much water per person, how much I'm spending per person on water, I need to invest in that kind of metrics, because that will guide the kind of actions I will take to conserve water and not make a mess of it or lose it. Now we have materials and resources. Our material, the entire built environment, we use materials and resources. We use take facility management, for example. We have all kinds of chemicals that we use in facility management. How does these chemicals affect our sustainability score or our analysis of sustainability? Chemicals come from the earth. They're extracted. We extract them sensibly and use very little, as much as we can, as little as we can. When we use them, we accumulate waste. Before the waste, while we are using them, we have chemical impacts on the environment, on the health of people, inhalation, lungs issues, skin exposure, and all that, all the other, and then even more serious cancerous, carcinogenic impacts of materials, all the way to what we have as the byproducts or the leftovers that we have to throw away. Where do we put them? We may end up putting them back in the earth in the wrong way. Instead of processing them into probably some useful components, we probably just go ahead and dump them. There was a case in point where we had, because we could not just take our fluorescent tubes and chuck them in the bin to go with the normal refuse. And why is that? It's against the law to allow heavy metals in our assets or our environment mixed with things that go to landfill. So we had this stack of fluorescent tubes, thousands of them. After a few years of stacking them, we can't just throw them away, it's against the law. We had to find a company that does mercury extraction. So they will take all these tubes into their lab or their factory, and then they will systematically extract the mercury embedded within them before they will now recycle the glass and the metal that makes up that. So the budget for that project was 7 million naira. Sounded ridiculous. Why would you spend 7 million naira just to throw away your fluorescent tube? But we'll do it because, one, we are obedient to the laws of the land. We want to be compliant. We want to work within the path of ethics and integrity. And two, because we want to be sustainable. We want to ensure that our use of materials does not create a vacuum that will be too hard to fill, or does not create a waste that fills up and contaminates the environment and does not impact people around. You've been to some construction sites and you see the level of dust. You see some factories emitting all kinds of fumes into the atmosphere. We need to be very careful because all of these things affect us as humans and our businesses. Then workplace management, work processes that have environmental impact. This is closely tied to quality of services, but it looks more at our built environment, not necessarily on the environmental impact. It looks at the kind of things we do in the work in the work environment. So the kind of furniture, for example, how tightly packed our sitting arrangements to save money. Of course, we want to save money. Our use of things like paper instead of digital means of recording or keeping records and so on and so forth. You know, as well as all the other things I have described. IFMA sees these 8 categories as areas where FMs need to focus and create benchmarks on how you are impacting the environment in these 8 areas. And that's what we call sustainability reporting. So as FMs, as you advance in your career, you should be able to make some notes on how you are doing with regards to sustainability broken down into these 8 categories. So looking at the 8 categories and kind of fixing it into the work that we do as facility managers, you can categorize them into inputs, processes, and outputs. Inputs are those things that we need from the earth. Processes are the things we deliver, the services and spaces. And outputs are the things that we dump back into the earth. So energy, water, materials, and resources are the inputs we take from the earth, and we provide workplaces, indoor environment, and quality services for people to function and live comfortably. And then, of course, there will be the waste and site impact. That is what we are doing to the earth. We need to consider sensibly using the inputs without waste, taking inputs and processing them in such a way that we will not only not be wasting, but not also be misusing or using them for functions that are not necessary, or even making people uncomfortable in the process of using the inputs, energy, water, materials, and resources. And then when it's time for the waste, we want to minimize the waste, want to minimize the side impact. If we cannot totally eradicate it, we slow down how badly we do when it comes to impacting our environment in this process. Businesses would typically focus on their profits. So what we call a top line and a bottom line, okay? So if you are selling or making revenue as a business, we say your top line, that's where we look at all the revenue you are getting. But your bottom line is what is left after you've taken away your expenses or your cost of goods sold or your direct cost or whatever cost that goes into that business, right? So your bottom line is what you can describe as your gain, as your main output from the whole process. If I start a business, or you start a program or start doing anything, there's always that view of what will be the main impact, what will be the main results from this effort or this endeavor, right? That's the bottom line. And for so many years, the world has looked at business purely from a parochial view of capital, economics, funds, finance, money as the one and only bottom line. You know, it's gotten so bad that even so-called non-profit organizations have taken the surplus mentality from the financial or economic standpoint to the level where nothing else matters, right? Until recently, the world became more sensitive to its environment. So people became more conscious about the impacts of capitalist exploitation of the environment and how that's going to affect future generations. So people started making decisions about organizations that are exploiting in terrible ways and making such huge negative impacts. And companies began to realize that, one, they were no longer making the money as fast as they were making it before because people are becoming more sensitive to their nonchalance with regards to destruction or degradation of the earth, right? And that's beginning to make people not to buy their products or services. And then, even for those who still think they are doing well financially, the perception of the public of such organization is also negative. So you hear people say things like, oh, well, we have to buy salt because we can't do without salt. But this company that is holding a monopoly of salt, for example, they are this and that and that. There's usually that bad press, that bad publicity that goes with not having any consideration beyond economic or financial bottom line. So organizations now have to look out and see how to use sustainability as a tool for rebranding, repackaging themselves, showing their real impact and care of the environment and the people. And that's what brought about the triple bottom line. So companies, organizations can now have the economic or primary bottom line, which is the financial, have impact on people, which is the social, and be able to also score points on how they are doing with regards to their impact on the community, on their workers, and to the world at large, and also the environment. How are we contributing to regenerating the environment? Are we part of degrading and destroying it because we are so selfish and greedy, right? If we have been investing in the environment, we also have another bottom line there where we can actually say, these are the amount of carbon footprint we have reduced and saved. This is how much pollution we have saved from the earth. This is how much we have impacted the environment by setting up schemes for trees planting, for example, to help to mop up all of this carbon surplus that the earth is experiencing. So in essence, the triple bottom line looks at how much you make as an organization, which is the economic bottom line, how much you impact on people, which is social bottom line, and how you impact on the environment, which is the environmental bottom line. And this is sometimes called people, planet, and profit. So you hear of the 3 Ps, PPP. It used to be just profit, but now it's profits, which is the economic, people, which is the social, and planet, which is the environment. So if you hear people talking about sustainability and talking about PPP, triple bottom line, they're talking basically about the people, planet, and profits being the social, environmental, and economic bottom lines of businesses. So as facility managers, how does this affect us? We are not supposed to be removed from the destiny of our organizations. That's why in the strategic facility planning class, we talked about how to do all of those SWOTs and all of those other scenario planning and analysis to help come up with ideas that can help our organization stay on the path of progress and growth, right? So because of that, we need to also understand how we as facility managers can contribute to the triple bottom line. On the economic side, we know that we can save costs, we can optimize value, we can do this and that so that we can spend less to get more, in terms of value. But on the social side, we are even more directly involved in impacting the lives of people, especially people within the organization and the communities that we serve. We manage the built environment, right? So the social and the environmental are now heavy on us as facility managers. So you must have baselines, you must have best practices and benchmarks to follow, and you must have goals set to achieve results in the area of social, environmental bottom line, while we also contribute to the economic bottom line. But then there are intersections. At the sweet spot between the social, environmental, and economic is what we have the sustainable, right? So if your operation is sustainable, it means that it fulfills the requirements of economic and does not rob social and does not rob environment, which means all these 3 bottom lines are being met satisfactorily, continuously, perpetually. Then you can say your operation is sustainable. If you are reducing costs, you are making economic bottom line increases. But if that cost you are reducing is affecting people's eyes, for example, you are putting dim lights to save currents, save electricity costs, for example, what are you doing? You are saving or making progress on the economic bottom line, but you are now creating a deficit on the social bottom line because you are making people to go blind, right? Or you are making people to endure cold urine in their bladder because they cannot flush the toilet more than once a day, or you've created some kind of policies to meet different kind of bottom lines that are not affecting people. So bottom line here is you must have that way to analyze whether a project, whether an idea, whether an initiative you are bringing on board is going to be fair or create equal positive outcomes across the three bottom line, instead of just focusing on one bottom line to the detriment of the other. So if you are doing that analysis, you're asking if this idea or initiative is equitable when you are talking about economic and social intersection. For example, if I'm saving costs, am I having a negative impact on people? Or if I'm having a positive impact on people, am I losing so much money that we're no longer profitable? That's equitable analysis. Then bearable, impact on people versus impact on the environment. Oh, well, we have to accommodate 1,000 people. All right, so how do we accommodate 1,000 people without cutting down trees? Okay, so how can we cut down trees, accommodate 1,000 people, and still have enough vegetation that compensates for the trees we are going to cut down? That's what the bearable analysis is trying to do. And then the economic and environment is talking about viable. I want to preserve the environment, but at what cost? Why am I in business? If I'm in business to make some gains or some returns, I'm not a charitable organization, then it will not be viable for me to put all my investment in protecting the environment and not make anything out of it. So I want to have a viable balance. So that viability is talking about the balance between the environment and economic consideration. In all, you must consider the triple bottom line, and you must do this equitable, bearable, or viable analysis before you can put the word sustainable to any idea, any initiative, or any concept. And to look at it in reality, the world is in a dire strait when it comes to sustainability. I think to some extent, I might just be philosophizing here, right? The Earth needed COVID-19 to take a break. We were running at breakneck speed to the end. So I think COVID-19 came to kind of, just put a small wedge and slow down the world. I mean, for the first time in almost 30 years, some cities in this world that we're in that had never been free of smog and fumes and all those heavy carbon clouds cleared up in 2020, cleared up. The rate at which fossil fuels were burned to produce all kinds of junk the world needs for all kinds of entertainment and fun life that we are trying to get for ourselves and keep money flowing. Fossil fuel burning slowed down. And one would have thought that with all of this slowdown of the economy and all that, there would have been a stronger economic collapse or a depression coming out of it. But that's not what we are seeing. We are seeing a very quick rebound. So the Earth probably took a break just to breathe in a bit instead of blowing up. I mean, think about all the natural disasters that slowed down last year. We know how many wildfires that did not happen. Some still happen, but we know how many usually happen on a year-to-year basis. Even flooding reduced significantly in most parts of the world. It's just remarkable, but that's me philosophizing. The point I'm making here is that the rate at which we are running, burning, and cruising is not sustainable. So that's the truth. People live in buildings. The air quality in buildings, the indoor environment quality in buildings is now so bad that if you are confined to a building throughout the day for weeks and months, you probably don't know what you are missing. You're probably losing your health very fast. And that's the lot of so many people, okay? I've talked us through this analysis of how to make choices using the sustainability or triple bottom line. So how do we as facility managers impact, our organizations, our environment, and bring in some sustainability into our organization? So let's look at the social measures. Involve in your involvement in your community. This might just sound like, oh well, I'm doing my own thing, right? But every time you have a facility in place, you are going to emit some generator fumes. You are going to bring out some refuse, and you're going to throw away some things, and your compound is going to have some storm water that is going to be washed out and washed into the environment. So be part of your community security efforts, environmental cleaning efforts, contribute, sponsor, fund, and support community activities to make the environment better. Don't be the one that always feels we have all our solutions self-contained, that we don't need to be part of the community. Then think about the well-being of the occupants in your facility. I have actually worked in an environment where I was the head, I was the facility manager. My own office was not having sufficient oxygen, and I was having all kinds of illness and stuff. Clean, brand new office, but within 2 or 3 hours of coming into that office, I'll be ill. So ill that I would not be able to hold, my head up. But when I get home, I'll be well. It was repeated for months until I discovered that, I might have all the pecs and the, luxury around me, but without oxygen, without adequate oxygen, good quality air around me, I'm actually useless. It turns out that the cleaners come into that office, they clean up the place, they spray all kinds of chemicals, they never open the windows. And then they put on the split air conditioner. So the air conditioner, recirculates all of that air, and it makes it look as if everywhere is clean and tidy and scenting well, right? But what had just happened is that the chemicals that were sprayed and used for cleaning oxidizes the little oxygen that was left in that environment. So by the time I come in, close my door into the office, I'm virtually struggling to stay alive. And many people don't realize how bad indoor environment can be for their occupants. So have, as part of your preventive maintenance program, or as part of your building evaluation or condition assessments at some point, do indoor air tests to kind of analyze the air quality in your indoor spaces, and then do as much as possible have mechanical systems that introduce fresh air into your spaces. And please, when you are bringing mechanical systems that introduce fresh air, don't go and site the outdoor units close to a generator or a fume producing machine, because at that point, you're not getting fresh air. You make sure it's actually positioned out where fresh air can be brought in. Because of course, many FMs don't even know that the split unit air conditioners that we use in our houses don't bring in air, doesn't bring any air. There's no contact between the inside and the outside space in a split air conditioning system. It's a closed system. The entire indoor and the outdoor is in a closed system. So no air is admitted into the system. So if you are using a split unit type air conditioning, you must be ready to provide additional ventilation opportunities to allow fresh air to come into your space, right? So the well-being of your occupants. And then the safety of your environment, trips and falls, electrical exposed cables, all kinds of stuff that people have to basically be tiptoeing or watch their backs or be careful not to get injured in your environment. You don't want that to be the facility that you are managing. So that's part of the social measure. For the environmental measures, think about your waste reduction, energy consumption, recycling programs, all the things that you need to do to improve the organization's carbon footprint or reduce the carbon footprint, including the use of toxic chemicals, glues, paints, oils, fuels of different assortments that we use for different things. We need to be very careful how we allow them to, interfere with human life or the environment that we manage. And then, what about the financial measures or the economic measures? I think this is where most FMs can easily relate, right? We want to lower costs, we want to increase asset value, higher return on investment, increase our efficiency, and so on and so forth. You know, this is really where most owners, landlords, employers, you know, CEOs focus and try to, you know, beat you into shape, right? But try to get the message from this lesson. You do this in addition to the other bottom line, and be able to make a case for that understanding that we need to focus on the triple bottom line as much as possible. So not all organizations will jump on when you talk sustainability. No, you can't impose it. You cannot bring it up as if you can't bring it up as if it's compulsory, because really at the point where we are in most countries, especially in Africa, sustainability considerations are actually ethical approaches. It's not legally binding yet. Organizations are not legally bound to have sustainability as a focus or main thrust of their strategy, right? So you're going to be in organizations where you talk sustainability and sometimes you sound like you're speaking Greek, okay? So the whole idea for us in this class is to get you to the point where you can use it to justify initiatives. You can bring in initiatives that can add value. While you are talking sustainability, you are actually showing the specific value that those initiatives will bring to the organization. And then you begin to write your strategy, your corporate plans, and your departmental plans based on some of those strategies that you have picked up with the sustainability consideration. Very important that we as facility managers can contribute this level of thinking into strategy in our organization, because that means that we are elevating our professional, elevating ourselves up to be able to contribute strategically. So basically, to start, it's important to know that you cannot do sustainability alone. There are organizations. An organization is a system, so you must get people to buy in into the program, so you can begin to start talking sustainability. Also look at what we call the low-hanging fruits. Low-hanging fruits, you have areas that are obvious, even a blind man can see, they say, about those kind of wastes, right? So you begin to pick those ones out, and then you now begin to do what we call baseline measurements. You need to know exactly where you are. So even if you're not yet trying to cut down on waste and all the other things we say in control, you already need to know where you are. For example, how much in tonnage or kilograms do you produce of this type of waste? How many liters of water or tons of water do you consume as a whole or per person? How much electricity do you consume? So just getting the sense of your baseline is very important, okay? And then as you begin to make progress towards putting initiatives in place and acting out on the simple ones. I'll give you a typical example. You probably think that, oh, we're wasting so much energy or cost using fluorescent tubes, for example, in our facilities, or using incandescent lights, okay? And you want to do a change out. You can go to management and say, you know what, let's do a change of all our lights, bring 11 million to change all our 1,100 light fittings. And they'll be like, what's wrong with you? Where do you think that kind of money is going to come from, right? Sustainability could be dead on arrival with that approach. But if I come and say, you know what, every month I do a typical change out of maybe 100 of those bulbs, okay? And they are changed out across the whole facility. And I say, okay, fine, my facility has 20 spaces. So if I'm going to change out 5% of light bulbs across the 20 spaces, I might as well just take one space in that 20, out of that 20, and do a complete change out to an LED fitting using my operations budget, maybe slightly higher, maybe the same amount, right? But instead of buying those incandescent bulbs to be changing or light fluorescent tubes to be changing across the facility, I'll use all of the money for this month's replacement of light fittings to change one room. So all the good lights in that room is used to replace the dead ones elsewhere, while I put brand new LED systems here. Of course, I'm not coming back next month, next 2 months, next 3 months to that stage, because most of our LED fittings will probably last for 2 years before they start giving you issues. So the point I'm making here is that you can actually go in a very use a very mild approach. Instead of coming back to say, oh, we have done our sustainability planning, we need 20 million to do this and that, right? So that can lead to things being killed. Now, in today's world, in the past, sustainability measurements and metrics used to be, so much work. You have to install meters here and there. You have to have log books. You have to have waste consignment management system where you are weighing every refuse and recording. Today, all of that data can be accumulated using sensors. There are sensors that can be placed in your waste bins to weigh them as you're putting things inside and removing them. Sensors, occupancy, sensors for metering water and electricity, and sensors with Internet of Things nowadays even allows that data to be automatically fed into analytic tools on the cloud that can give you all kinds of measurements and outputs that you need to further your sustainability goals and achieve your results. Okay, so a few steps. I've mentioned this before. You can't do it alone. There must be some kind of engagement, senior management, at least somebody or some people at the top need to buy in. Okay, and then you need to make a business case that demonstrates that the organization is going to have some benefits that are tangible before they begin to even consider sustainability consideration, except you're in an industry where the industry standard or regulatory standard in that industry begin to push organization by force towards sustainability. And then as you begin to engage with people, of course, senior management are brought in, you now get people at various levels in the organization to form informal committees, people who, focus groups, launch meeting chats about sustainability, because you need to get as many people as possible in. Your job at that point is to share the vision, is to get them, fired up into thinking, yeah, this can work. I'm sure this is something that I would like to do for myself and for my children and future generations. And then as you move on, start getting approvals for certain activities, you begin to get, you start documenting, your plans in terms of what we'll do quickly now, short-term, mid-term, long-term plans. You start documenting outputs and results, because of course, since you have a baseline data, as you are putting in place this initiative, for example, you start recycling your waste, starting with paper only, start putting paper elsewhere instead of dumping paper with every other waste. That will go a long way in at least getting you to say, oh, we've made a little gain. We've done paper recycling as an effort to improve our sustainability. I'm going to give us a little break now, and then we'll come back and look at energy. Haven't gone through the session on sustainability. So 5 minutes is all we're going to have. Thank you very much. See you soon. Okay. So let's talk energy. We can all relate with the sources. The fossil fuels are the ones that are tapped from the earth. Fossil because they've been accumulated through thousands of years of decay. So we have the coal, we have the crude, we have gas, we have bitumen, we have so many other natural resources that come from this source. We have the renewable ones. They are the ones that come from mostly from vegetation or vegetable materials that come from water or other sources that don't necessarily get used up, or when they are used up, they can come out replenished as quickly as possible. And then you have the nuclear. Nuclear is a continuous counter-reaction process that generates an energy in a very delicately balanced or controlled environment. And then, of course, we have the perpetual, which is the solar. Most of the time we add the solar energy into renewable because of the storage systems that solar power management systems normally will go through. You have to have some battery banks, you have to have some other input, but in essence, when it comes to the power of the sun, you can call that perpetual because it never gets diminished. No matter how much you use the sun, you always have enough. It doesn't ever go down, right? So for us as facility managers, knowing the sources of our energy is very important. And I tried at the beginning to give a little insight into where our public supply comes from. It used to come mostly from the hydro dams. Now, a lot of it comes from the thermal powered gas plants, right? So these are hydrocarbons, gas coming from petroleum exploration being used to power the turbines that are generating somewhat up to half of our power supply right now in the country, right? So that's how far we've gone. And then if you now add that to what we as individuals generate using hydrocarbons, pure petrol, diesel, and kerosene in our various spaces, then you'll be shocked at how bad things are, right? So the government has the means with some large corporations to use renewable opportunities or renewable sources, for example, like build the Mambila power dam, for example, and such huge projects. But instead, we have less than 5,000 megawatts capacity. And you know what we all have in our various homes and factories and offices and businesses in Nigeria? I think latest estimates puts it at about 18 times what the government, what we find from the public system. So if we were to pool our energy that we all generate for ourselves into a measurement to bring it out to compare it to what we have from public supply, we will be doing 95% compared to 5% of public supply. And that's a real embarrassing statistics, right? But for us as facility managers, we just want to be sure that as much as possible, we don't contribute to the problem of energy source and energy wastage. So we concentrate on improving energy performance. Now, if you have increased activity, like you have a school, you're running a school that has 1,000 pupils. Your goal is to increase that number from 1,000 pupils to 5,000 pupils, right? You don't necessarily intend to keep your 1,000 kilowatts per month consumption at 1,000 kilowatts when you are ramping up your school attendance to 5,000 students or 5,000 pupils, right? You want your productivity to increase. I'm running an office. We used to have 200 workers. The office is growing. We now have 1,000 workers. Yes, it's energy that will fuel that. The factory that used to produce 1,000 pence now produces 5 million pence a year, it means energy use will increase. But as facility managers, our main concern is not on total energy consumed, but on what we call energy performance, or the rate at which energy is consumed per output. Per output. So for you, a square meter could be an output because it's a measure of how much you're managing. A person who works or lives in your space, or a student in your school, or a product that is being produced in a factory that you're providing power for, and so on and so forth. You must have your focus on how the energy used relates to a unit of output. That's what we call energy performance. So your total can go up all at once, but your energy performance must improve. And for you to improve, you must keep seeing the rate or amount of energy used per output measure, or a energy use driver going down. That's the whole idea. So whatever the ratio you are using to measure your metric, it must be going down. Your total can go up, but your average or per use should be going down. What are your goals, facility managers? You want to use less energy per output. You want to use more from renewable sources. You want to use energy in a more socially and environmentally responsible manner. You want to understand as a facility manager how energy is consumed in your facility, how much you pay per kilowatt hour, whether you are on maximum demand and how that is calculated. You must know, you must have an idea of what your energy consumption pattern, energy profile is in your facility. So I would normally recommend you at this point, ensure that you do a regular energy audits for your facility. Okay, and that's one of the major service that's provided by Max-Migold across the country today. Just helping you identify in a simple process where every energy you are paying for goes into, develop your energy use profile, and also identify waste opportunities of savings that can go straight into your bottom line. So ensure that your core building systems are improved in efficiency. What does this mean? Many people don't realize that just by having a cracked window or a window not closing properly in one room that is served by 2 horsepower air conditioner, you can be wasting up to 25% more energy that air conditioner is consuming, because that AC is trying to balance or even out temperature when there's a lot of mixing of air between the hot air outside and the supposedly or expected cold air inside. So you're building your core building fabric, really, that's talking to the fabric. But again, your core building systems, which has to do with your HVAC system, the ducting system, electrical system, just making sure that these systems are having the best of installations, the best of maintenance. The moment your maintenance goes down, your equipment becomes defective, you are actually losing money through energy. We're not talking about the loss you make from breakdown of the assets. There are a lot of losses you are making from energy. First, an equipment that is weak struggles. It tries by its intention and design to produce the output you expect of it. So it will go out of its way by sucking up more energy. So every time you hear of noise in an air conditioner, in a fan or in a belt or something, or a vibration or increased displacements, you are actually spending more energy to produce those movements and those noise and those actions that are not necessarily adding value to you. So if you're actually measuring, you will know exactly that you are wasting a lot of energy because your building systems are not maintained or tuned properly. And then your occupants, facility managers must understand, you cannot do energy efficiency just like sustainability alone. You must carry the occupants along. People make all kinds of habits. Just the same way the average individual will eat less food of his own money that he bought than in a buffet that he's not the one paying for, or eat more because it's a buffet, everybody pays the same fee, and then go home with tummy ache. That's how people behave with energy. If they are not the one paying for the energy, they don't feel any extra need to be committed to saving it. I mean, test the average public utility user in Nigeria. When they are on estimated billing, they even put on bigger yellow bulbs and leave it on all day. Deliberately, I mean, they don't just care. You tell them their switches are broken. They will say, tune the wire together, leave it permanently like that. We're on estimated bills. It is that kind of criminality that leads into the situation where we find occupants frustrating the FM's effort. So the FM needs to find a way to, you know, play into the hearts and minds of people you are managing. Because no matter the technology you deploy, no matter the, you know, some FMs go around room by room, going to check that ACs are switched on and lights are put on. How long can you continue operating like that, right? You need to get people committed to it, up to the point where they can actually, they will learn to unplug their own laptops when it is fully charged, not to leave it continuously on power, or to leave phone chargers on the sockets, whether there's a phone on it or not. You educate, you orient, and so on and so forth. Because if they are not carried along, sorry, you'll be wasting so much and you won't know exactly how to get around the issues you are dealing with in your facility. And energy loss is often hidden. When you are paying the bill at the end of the month, it's all you see, right? It's the bill, right? And I mean, they showed you the kilowatts you consumed. You really can't tell exactly where that kilowatts was used. And that's why we encourage that we do not just main metering, but sub-metering and circuit level metering. Having data at 3 levels at least in your facility will give you a lot of information that you can use to make decisions. And then carry out energy audits. I talked about this, a service we provide, but if you as a facility manager just do your inspections with focus on a certain area, I'm doing electrical inspections today, I'm doing cleaning inspections tomorrow, I'm doing health and safety inspection the next day. On one of those inspections, you know, generate simple templates that you can download from the internet to record your observations. For example, you have lights. Maybe you have lights that are not energy efficient. How many of them are energy efficient compared to non-energy efficient? How bright are your spaces? How effective is the light you are providing? Some spaces are too bright for the purpose of that space in itself. So do that audit. How many of those lights are heating up? You know, every time you're supposed to have lights and all you are feeling is heat, you are wasting energy, right? Because it's not heat. You didn't put the light there to heat up the room. You put it there to provide light, right? But the fact that you are feeling heat means that energy is being converted towards heat. And that energy that is being converted to heat, you are paying for it to heat a space that you are actually providing air conditioning to cool. Is that not an irony? You can't pick all this out until you settle down to do this audit and look around and look at your building envelope. I talked about window sills, window liners, window handles, cracks in windows. You also think about your walls. You know, are they soaking? Are they cracked? You know, do you have cladding that are giving way, that's allowing air to or temperature to exchange from inside to outside? So in essence, if I'm doing my building envelope audit, for example, first I want to be sure that when inside is cold and outside air is hot, if I fill my building from outside, it should also be hot. Whereas if I fill my building from inside, it will be cold. If I fill my building from outside and it is cold because there is cooling inside the building, I am losing money. I'm losing cooling. In the UK, for example, in temperate environments, this is a big deal. It can make the difference between whether you're going to prosper or you're going to die in poverty because of energy costs. Because your bill for a month can be 100,000 naira if you convert the pounds to naira in terms of 200 to 50 pounds that you pay for energy bill in a month. But if your building fabric is so porous that the heat signature is emanating outside, your bill for that same level of temperature you experience inside can be up to 600, 700 pounds in a month. So you can work all as hard as you want and don't have a proper building fabric or building envelope, and you just be throwing that money away because nobody cares. And if you want to know, they use these thermal imaging cameras, the same type of cameras I recommend for electrical inspections to check whether it's warming up inside. Just use it to image your building, wall by wall, elevation by elevation. You will see a plotting of where, if inside is hot, should it be hot outside? If inside is cold, should it be cold outside? Because the cold areas will be bluish, the hot area will be reddish, and you have all color spectrum from green to amber all the way to that red area, right? So that's how basically it works. And then your HVAC. In this part of the world, we mostly deal with air conditioning because we don't have a cold problem to deal with heating, but we need to have more ventilation and air conditioning. And much of our energy consumed goes into air conditioning. So we need to make sure that we buy efficient air conditioning systems and then we maintain them in such a way that they use less energy. And then all the other facility equipment that we use. Auditing is one key way, looking through all of the systems and building fabric, and then metering and sub-metering, like I explained before, are other ways we can ensure that we have energy data that we can act on. If people put things on and leave them on and put them off before you come around, you don't know they were on, right? But if you have systems, like this digital meters that are IoT sensor enabled that can pick up this data and give you that visibility anywhere you are, you will not go wrong at all. So one of the things we're going to introduce to you at some point in this program is how you can use the Eniscope energy management system that we also bring out from the UK to help you monitor at a micro level, per second, per minute consumption, per circuit. It's just something that is phenomenal. If you think about your energy cost today, calculate 10 to 15% of it. Metering at the circuit level can already save you that amount without any other retrofit or any other investment. So that's something you can think about. Then for those of us on maximum demand meters, skipper meters, all of those kind of meters that we don't even know how they read it, they typically use our peak because we are high consumers. They use our peak, and so learn how to manage your peak using load shedding and load shifting. In shedding, you basically kill some activities that are non-value adding. You don't move them around. For example, people are on break. Tell them to leave the office, for example, and shut down the air conditioning so that they can do two things. They can stretch their legs, they can be healthier, and then you can save the energy and reduce consumption at peak. Your bill will drop drastically. Then load shifting. There are some things that can be done at non-peak periods that are actually happening at peak period because we have automated. Your sewage plant is on automatic. When the sewage builds up to a certain quantity, the plant picks up. And you know that quantity will be reached easily when the office is occupied, or when the school is occupied, or when the church is fully occupied, right? So why do you want, at that time when all the laptops are connected, all other equipment are connected, is when the sewage plant should work? No, I will switch that from an automatic pickup at a certain level to a pickup at a certain time. So I will tell the system, treat by 4 p.m. to 7 p.m. And in the morning, treat again by 4 p.m. to 7 p.m. so that the whole chamber is empty for the day's collection. But of course, I would have done my analysis to know that my daily consumption or my daily production of waste does not shoot over my capacity to hold to the off-peak, because it doesn't make sense for that machine to be coming on at that time, or for pumping machines that are pumping water up to a tank that are going to be used by gravity to be pumping us at the same time all the equipment are on in the facility. We don't know really what's making our bills to go up because we are not checking, we're not doing any of this analysis. And then look at all of the big macro, small, micro energy waste. For the macro, we talked about the building systems, we talked about your building fabric. These things, there are system reviews that looks at the entire building. But again, the micro ones are those small things like laptops being left on, like chargers being left on, like TVs being put on standby and left on standby, decoders and the rest. If you're not going to use them for weeks or days or hours, put them off, let them go to sleep completely, let them die off, and then when you need them, you put them back on. Don't leave them idling. I know some people have never put on their laptop for months or years. They just close it, and then it trickles out, loses 20-30% before the next morning. They continue charging it again all day, and they just do that, and you just keep losing. So those are the micro and macro ones. But you don't have the maintenance-related issues, where I said that your equipment will keep drawing power to keep feeding or serving you. So if you have poor connections, if you have undersized conductors or cables, or you have leaking insulation, or low power factor, or voltage imbalances, you are actually losing a lot of power. Your calculations will just be going, you will not know that you are not having a good, you're not getting optimal use from your bills. For example, if the public supply feeds you 240 or 250 or 260 volts, your bill will be substantially higher than what you would have used if that consumption came at 220 volts. But if you're not measuring, you don't even know that you're wasting money, because, how would they calculate it? Just multiply it by the other factor and give you your bill. That's what the meter does. Okay, so let's be careful. Talk about sub-metering is very important, because you cannot measure, you cannot manage what you cannot measure. You cannot manage what you don't know. Now, that's why you cannot just wait for your bill to arrive at the end of every month to see. And people take their bill to management meetings and start philosophizing on how to reduce energy, how to save energy. You're just talking all those theories until you can actually pinpoint the things that are actually costing you. I've seen solutions that there will be a lineup of items of savings opportunities, and next month the bill will go higher, even with all the effort. You know why? They're not even checking, they don't know. Okay. When you have a large pump automatically filling up a tank, and there is a plumbing bust in one of the major pipes that is emptying out the tank every 2 hours, that pump is coming up to pump every time the tank goes down, and nobody is checking because the drainage is sealed and the water is just going off. The pump works itself, into overdrive, goes bad eventually, but between now and then, you see the energy consumed. But if you have metered that pump and you have an insight into what that pump is doing, you get a sense of, oh, goodness me, why is this pump virtually running around the clock? Or why is this AC for this meeting room that has 2 or 3 meetings in a week? Why is it showing energy use for the whole week? Probably one person goes in there to put his head on the table, put on a large 10-ton AC to cool himself, and that's as much value as you get for that kind of energy consumption. So let's be careful to make a case for proper metering so that we can have ideas or information on how our facilities are doing. All right, there's an assessment for this one. I expect you to work on it today. Let's have your questions and have a discussion as we wrap up.
Hello, Mr. Paul.
Hello.
Good evening. Hello, everyone in the class.
Good evening. Welcome.
Yeah, thank you. I'd like you to please further explain, because I understood the load shedding.
Okay.
Yes. I need some further explanation on the other one.
Load shifting. Okay.
Yes.
Okay. So while load shedding is to cancel an activity, load shifting is to move the activity out of your peak time into your off peak. For example, I can program my pumping machines to fill up all my tanks in the morning, which is off-peak, right? So that the pumps will not automatically come on in the afternoon. I will now use a timer switch instead of a flow switch. That has shifted that load away from my peak period. And then I can move all my laundry or my sewage plants to process in the evening instead of at the peak time by rescheduling my staff who does laundry. So instead of bringing them to work during the same time as everyone else, I'll give them evening shifts for laundry. So you can come and do laundry between 4 and 9 p.m. at night and do all of that. So those machines can work, they consume a lot of energy. That energy should not be consumed at the same time as my peak. The reason why I need to work on reducing my peak is because my peak is factored into my billing. So every other person who is not using maximum demand, point load, or skipper meter, any of those kind of arrangement that makes you a special candidate or special customer, especially in the commercial space, right? Their bills are usually calculated as how many kilowatts by how long. So if I'm using 1 kilowatt an hour, that's 1 kilowatt for that hour. If I'm using 2 kilowatts for the next hour, that's 2 kilowatts. So my bill is according to the curve, under the curve. The area under the curve is my bill if I'm just a normal consumer. But if I'm a maximum demand consumer or a point load owner or consumer, it means that the power authorities or DISCO have provided additional capacity to accommodate me. I'm not a special customer. Because of that, they will use my peak to factor into my billing. In essence, instead of measuring me with the area under the curve, they will measure me in a straight line at my peak. So my job is to make sure that where they put my level as my peak is dropped down by removing non-essential items, shedding, canceling them, get out of the office. I don't need to be cooling you when break time. That's shedding, right? And then shifting is moving the activity that I must still do, but I must not do now. I can do them in my off-peak time. That's load shifting.
Thank you very much.
All right, thanks. Tony.
Yeah, good evening, sir.
Good evening,
class.
Welcome.
Yeah, I just needed a brief explanation under the triple bottom line.
Yes.
I think you said something on social measures, environmental measures.
Yes.
But on economic measures, I wasn't too clear of the explanation this.
I actually didn't spend time on economic measures because this is what FMs beat ourselves about every day. Don't spend too much money. You're always spending too much money. Reduce the money you are spending, isn't it? Make sure you get the lowest prices for everything, right? So this is basically what our entire profession is focused on. And I highlighted that all of this long-term saving, higher efficiency, increased asset value, and lower operating costs as aspect of the economic measure should be things we are doing as FMs, but should not be the only things we are focusing on. We should also focus on the environmental and social measures.
Social measures.
Yes.
Thank you, sir.
You're welcome. Thanks. All right. So let's hear from you, Adedayo.
Yes, sir. Thank you for the lecture, sir.
Okay.
Yeah, you talk about voltage imbalancing.
Yes.
In a situation whereby we manage a multi-tenanted building and even on your generator, when you're on your generator, you still have voltage balancing. What can someone do about it to stabilize? There are devices that do this. Okay, there are devices that do this. There are power correcting devices. That's what I would normally advise. Then the second thing is that when you have a three-phase connection, yes, sir. Distribute the loads. Most of the time the problem comes out of three-phase connections feeding single-phase loads. Okay. You understand? So yes, distribute the loads. For example, you may have 24 circuits or fuses in the distribution board. All of those fuses are all single phases, right?
and they
Yes,
are
sir.
all different. They're all rated differently, and they all carry go for different size of appliances or equipment, isn't it? Now,
Yes, sir.
as you feed your three-phase load into that DB, you are not feeding three-phase into each one. You are feeding single-phase into each one, isn't it? So
Yes,
you need to do a study of how that load is being carried by the three phases so that you can balance it. You probably have a certain 60 amps fuse, 4 of them on one phase. And then you now have 5 amp fuse, 5 amps, 5 of them for sockets. Like you have 5 10-ton ACs or 5-ton standalone ACs, for example, connected to one phase. Maybe they are all single phase connections, right? And then you now have all the lights connected to another phase. You already created an imbalance by the way you have put your loads into those 3 phases, right? It will cost you a lot more because when they are billing you, a 3-phase bill is a 3-phase bill, different from a single-phase bill.
Yes.
So that's why you need to do that study. Get electrical engineers in to do balancing for you, do manual balancing. And then when you have those ones that have to do with phase failure, phase reversal, phase issues, you have other equipment that can also help you do that. Olayemi, you want to help me out?
Thank you, sir.
You're welcome.
Yeah, thank you, sir. Thanks for the elaborate class, sir.
You're welcome.
Yeah, well, what I can just say concerning that also is that you have actually mentioned the right word, is to look at how much power is connected to each of those 3 phases. So with that, you'll be able to know how to redistribute them within each of its spaces so that you can have something close. You cannot have exactly the same figure on a load on each of the line, but you can have something close. To, so that it can be balanced.
Yeah. Thank you.
Sir, I have my own personal question, sir.
Yes, go ahead.
I want to ask, how can we measure the oxygen level in a office space?
Yes, you can. Actually, we don't. The common tools we have are carbon level measurements, carbon meters, right? So because we are breathing out CO2, right, and taking in oxygen. When CO2 becomes very high, we know that oxygen is now very low.
Exactly.
So CO2 sensors are very common.
Okay. So that we measure it against a particular range.
Yes, the WHO standards. There's the WHO standards. You know that a high quality air has certain amount of nitrogen, oxygen, hydrogen, carbon, and so on and so forth. So you just need to research that and benchmark it against what you're getting in your results.
Okay, sir.
And then some labs actually do air tests. They will come to your place. They will, do analysis of your air. Just they will do water tests.
Okay, but doing that, I think might not give us something that, sometimes this concentration we are talking about, this carbon concentration, is dynamic, depends on.
It will be different for every room.
And for a living room, what I mean is that something that can be telling you in real life.
Yes.
Or maybe it can even trigger an alarm when the load is higher than
CO2 sensors. Get CO2 sensors. Get a CO2 sensor. We have such solutions because what we are doing now with our energy management system is that sensors that measures your diesel, liquid levels, your water use, your air quality, your occupancy, your moisture level, your air temperature can be installed across the entire facility, and all the data will be aggregated into one portal.
Okay.
So you see,
that would be good.
Yeah.
Thank you, sir.
You're welcome. Fatima, last question.
Good afternoon, boss. Thank you very much.
You're welcome.
Okay, my question here is, you are under tremendous pressure to keep managing your energy, but you think you've done all possible stuff to ensure you are on target. You've changed your bulbs to all LED. you ensure you get a single point to put off electrical items before going home. Still, you are still rated high on your energy. But listening to you just now, I made to understand at times even some sockets, or maybe the ACs, you have the technical terms to use just now. Me now being a layman on energy, what do I do, Paul, to be sure of what I'm telling management that, look, this is what is causing my energy?
Okay. You need to meter every circuit. It's called sub-metering or energy management system. And these are devices that are very, very simple devices. A small device, so if you have your distribution board like this, I'll put a small device beside your distribution board. It's a computer. In your distribution board, you have all of those fuses. One is for AC, lights, sockets, UPS, all of those things. They've arranged them inside the DB. If I put this small computer on the side here, I will just hang current transformers, little, they look like this. They look like this. You see this image?
Yeah.
See this image? Yes. I'll just put something. What I'm describing is not a meter like this. It's a small box. I'll drop a brochure for you guys in the platform so you can look at it and get an idea of what I'm talking about. What this is doing basically is it's picking the data of what's happening inside this cable, and it is sending it into your phone and your laptop. So 24 hours round the clock, you can disaggregate every minute of energy used across the entire facility. So if you have that in place, you can beat your chest to tell management, we don't have a kilowatt hour being lost. Okay, for example, you probably don't know that people who stay back to work in the office are staying in about 20, 30 rooms, which are kept cooled and lighted for extra 2-3 hours. Whereas if you now know how much energy that 2 hours is costing, you can move 20 of them into one room once we close, shut down the whole of the office and say, this is our hot desk, where everyone that wants to work late can come to. And I can use that to save 19 rooms of energy use, because I now know if I don't have the energy management system in place, all my energy effort is still guesswork. I'm just trying my best. It's still guesswork.
Okay, quick one before you go, boss.
Yes.
So I have this smart metering.
Yes.
That is taking care of water, diesel, and the electricity.
Yes.
So I'll go and look at it. If what I'm seeing here is the smart metering, and then if I need to put this small black gadget on that same metering system to ascertain what you're saying now.
Now, your metering that you have right now is doing aggregate metering.
Exactly.
That's not what you need. You want a completely disaggregated metering that meters every room, every item, every socket, every switch, neatly done across the building. So instead of me having a 1 meter at the end points or the entry points, I'll have the meter on every distribution board. You know that in every floor, you have a distribution board where all the circuits of electricity is connected to. That's where I will place this computer box that will meter every socket, every fuse, every switch, every equipment connected. In fact, I can tell when people are in the space, because the air conditioning that is working at that time will be responding to more heat in that space because of the kind of data I'll be generating. So it's that level of detail that you need now. So if your energy costs per month is already more than 3 million naira, both for diesel and electricity combined, you already qualify for free installation of this energy management system, because what we do is that when the energy management system is installed, we take part of the savings to pay for the equipment in 5 years. So let's assume your energy bill comes to maybe $1,000 a month, right? And we install this energy management system. You don't even have to pay. From month one, when we use the intelligence and the data from this system to advise and make changes and controls, and the energy bill starts coming down, that savings is shared to recoup the funds used in installing these systems instead of outright sale. That's the model that we are rolling out now, and that's making a lot of sense, because what that means is that you don't have to budget capital investment for energy management system. The system is deployed to you for free, but with the understanding that you are spending so much on energy now that there's a potential for savings that can pay back for that investment. To give you data, sustainability metrics, and credentials, as well as cost reduction at no extra cost in terms of investment. I said I was going to be last. It looks like I'm going to accept Ibukun to ask a question now.
All right, sir, thank you. It's still in line with the last question anyway.
Yeah.
I just want to know how can we get this this meter, and all of the installation aspect too. Is it something that can be done by any electrical person, or
you don't need an electrical person to do the installation? It's a computer. It's a computer device, because it's non-intrusive. It does not connect with your cables. It hangs around your cables.
Okay.
You understand? So it's a sensing device, and it's a cloud-based data solution. So you can use your phone or laptop. So what we basically do, we just come in there. We will mount the box beside your DB, connect it to all of those fuses without interrupting the flow of electricity inside them, and the data is configured, to the cloud, and you get the data live, real time, everywhere. But before this kind of metering can be done, your DBs and panels must be labeled, because this is something that my team are in a very large terminal right now, a transport terminal, and we are trying to install, label and identify where each switch and circuit breaker connects to. You get what I'm saying? Because until you know that, you cannot actually replicate that inside the meter to know what is on at the time and what is off at that time. You understand? So that's the first thing that needs to happen. So check your DBs, distribution boards, to see whether they're already labeled. If they're not labeled, that's your first bet of point of call. We normally provide ourselves to come in for a small token, go and label all your DBs and replicate the way your DB looks inside the software, such that everything that is running is shown. We're not going to be doing labeling like circuit 1, C1, C2, C3. No. If C1 is industrial fan in meeting room, that's what is going to be written there. So when you are looking at the data, you're actually seeing industrial fan in the meeting room worked for 9 hours yesterday and consumed a cumulative this number of kilowatts. You now ask yourself, who used that space? If it's one cleaner that just want to cool his head off, accumulated 4,500 naira of bill for you, because you put your rates into the software, it tells you how much that thing consumed yesterday. You will not say, no, there's a cheaper way to cool your head than spending 4,500 naira on this industrial fan alone in this big room. Are you getting what I'm saying? Because I now have that data. Just the way I mentioned, you can move people and say, look, we have a new policy. By 5, we shut down the whole office. If you want to work late, move into this other lounge, which will be service. There will be tea, there will be coffee, there will be biscuits, there will be music, whatever you want to enjoy in that space. I'm saving all this energy because I have data on how much I can save now if I make that effort. So if I tell my man, look, don't worry, I'll buy biscuits and tea and coffee to entertain people who are going to be working late, it will just be like approved, because I'm going to be spending extra 5,000 a night entertaining them in that space than 5,000 times 20 places where they are already occupying and wasting all that energy. Because I have data, I cannot tell management this is what it costs to run this room for extra 1 hour. If I didn't meter to that level, I cannot say that. Most of the cases we are making for our management is not making sense, including the case to replace an equipment that is rated for 40 kilowatts is running 48 kilowatts. You don't even know. Management is telling you we don't have 2 million to replace it, we don't have 2 million to replace it. But if you use that extra 8 kilowatts times the hours it runs, you say, management, look, oh, in the next 9 months, we would have spent this money where I'm looking for in the energy extra that this equipment is burning right now. You get approved because you have data, hard fact, because you metered using an energy management system. So you can't do it. This age of FM is not the age of guessing what is going on and what's not going on. You need to see physically, you need to see those data from these kind of systems. Okay.
So we have to contact you if you want it installed,
yes.
right?
Yes,
Max-Migold,
I will
right.
drop the brochure for you in the platform, and then
Right.
you can contact us, and then the team will come and do a survey for you. All right, thank you so much. I hope you have had a good time. Have a good evening, and please do your assignments, the assessment for this class, and see you again on Thursday.
Thursday. Thank you.
Thank you. Bye-bye.
Thanks, bye.
Thank you. Bye.
Bye-bye. Thank you, sir.